right, hello, Algebra 1A folks. We're going over a quiz on scientific notation. So just a few notes, things to remember before we get started here. Scientific notation and standard form, changing between those, is all about moving the decimal point. The exponent tells us how many places to move the decimal point over. If we move the decimal point, we know what the exponent should be. And my shortcut to kind of try to memorize things is that a positive exponent means we will have a big number, whereas a negative exponent means we'll have a small number. So if we take a look at the first example together, our instructions for 1 through 8, we are to write each number in standard form, the regular way. So number 1, we have 8.42 multiplied by 10 to the 6th power. So that 10 to the 6th power, the exponent tells me I'm going to move the decimal point 6 places. Okay, and so remember that's part of this is moving the decimal point. The exponent tells me to move the decimal point 6 places. And since it's a positive 6, the exponent is a positive number, that tells me that the result of this is going to be a big number as opposed to a small number. So I'm going to put out the two options here. So this first option, maybe that I consider, is the decimal point is starting between the 8 and the 4. And so if I move it 6 places to the left, 1, 2, 3, 4, 5, 6, this is where the decimal point would end in standard form. That's one option of moving the decimal point 6 places. But let's see, what if I, instead of moving that decimal point to the left, I moved it to the right? Let's see what that would look like. So if I were to move the decimal point on the 8.42, if I move it the other direction, it's starting here between the 8 and the 4, but if I move 1, 2, 3, 4, 5, 6, and I end with the decimal point right there, that's another possibility of moving 6 places. So those are the two options. But if you remember that the positive exponent means we want a big number. This number on the left is 0 point something. This is less than 1. This is a small number. The number on the right is, let's see, that's 8,420,000. That is a big number. So since we had a positive exponent, I want the option that's the big number. So my answer option is over here on the right, 8,420,000. I guess I don't have to circle big number, box big number. But yeah, that's the idea. I'll give you one other way real quick, and then the rest of the examples we'll try to move a little more quickly here. But how else might we remember that 8.42 times 10 to the 6 would be the 8 million something instead of the 0.0? Well, that would be that a positive exponent is repeated multiplication. So if I write out 10 to the 6th in expanded form, and you might remember, well, hey, every time I multiply by 10, the result gets bigger. So 8.42 times 10 would become 84.2, times another 10 would become 842, etc. We would just keep moving that decimal point as every time we multiply by 10. And so doing it 6 times leaves us with, 8,420,000. Okay. Again, I'll try to go more quickly on these. Okay, but I'm going to jump to number 4 here. So number 2 and number 3 would be similar to number 1. You could think of it as repeated multiplication by 10, which means the results are going to get bigger and bigger. You could say the positive exponent tells you that you're going to have a big number on number 2 and number 3. But number 4 has a negative exponent. Now, as far as the exponent, I'm just going to say take a 4. I know it's a negative 4, but take a 4. The shortcut is I'm going to move the decimal point 4 places. But again, the question is, which way do you go? Do you move it to the left or do you move it to the right? And also, I'll put out both options here. So if I move that decimal point, it's starting between the 9 and the 3. That's where it is at the beginning. If I move it 4 places to the left, then it would end right there, and I get a small number, 0.0009374. If instead I move it to the right, I'd end up with a big number. So still with that decimal point starting between the 9 and the 3, but if I move it 4 digits to the right, then it ends right here, and that gives me a big number. That's 93,740. So it's one of these two, because the exponent of negative 4 means I'm supposed to move the decimal point 4 places. But this is where I would say, well, if I remember that it's a negative exponent, and so that means I should have a small number. Negative expo, as in negative exponent, means we should be getting a small number. So that means my answer would be the 0.9, or excuse me, 0.0009, this one. That would be my answer. That's 9.374 times 10 to the negative 4th. Again, another way you could think about it is the negative exponent being repeated division. I'll write that one out. So if you think about that negative exponent as repeated division, I've written out the expanded form there. Every time you divide by 10, the shortcut is that decimal point moves to the left. The results get smaller and smaller. So 9.374, if we divide by 10 once, it'd be 0.9374. If we divide by 10 again, it'd be 0.0. We'd have to scoot a 0 in there. 97349374, whatever. But yeah, eventually we would end up, if we do it 4 times, this is what we'd end up with there. So number 6 would be similar. Number 6 has a negative exponent. Number 7, I see a negative exponent there, so similar idea. You can think of repeated division with the negative exponent, or you can think about a negative exponent in scientific notation gives you a small number in standard form. Do maybe one more from this section. Okay, we'll look at number 8 here, because number 8, if you're thinking about how I talked about positive exponent and negative exponent, number 8, if you remember, 0 is neither positive nor negative. So you might say, well, what's going to happen here? But if we take the shortcut of moving the decimal point according to the exponent, an exponent of 0 means move the decimal point 0 places. And if you move something 0 places, or you do something 0 times, it means you don't do it. So this would be we don't move the decimal point. So the decimal point is currently between the 5 and the 6. And if I do not move that decimal point, this is what I get. Now, whether you call this a small number or big number, big number typically is 10 or more. Small number is less than 1. Well, this is in between. If you think of it as the expanded form, 5.62 times 10 to the 0. Well, since 10 to the 0 is 1, 5.62 times 10 to the 0 is 5.62 times 1, which is 5.62. So again, that exponent, thinking of it as repeated multiplication or division, but in this case, we're not repeating a 10 at all because the exponent is 0. In our expanded form, there are no 10s. There are 0 10s. So that's it. So maybe deceptively easy on that one. It can be tricky though. Okay. Let's do some going the other way, starting in standard form and changing to scientific notation. Okay, so on the same quiz here, going the other way, starting with standard form, the normal way to write numbers, and changing these to scientific notation. So the thing to remember about scientific notation looks like a quote-unquote single digit multiplied by times a power of 10, 10 with an exponent. So looking at number 11 to start with here, the single digit can't be a 0. So if I'm going from left to right, I go, looking for a digit that's not a 0. Oh, here we go. It's the 2. That's going to be my single digit. You might say, but don't you need the 9 and the other 9? I go, yes. So what's going to happen is the decimal point is going to end up, hold on a second. The decimal point is going to end up between the 2 and the first 9. So it's going to be, my answer is going to be 2.99 and then multiplied by 10 with some power, some exponent. And that's now the part to figure out is what's the exponent, okay? So 2.99. In my opinion, that's the easy part. You can agree or disagree, but can't be a 0, and it can't be like 29.9 because that's too big. Can't be 299. Can't be like 0.299 because that's too small. Then your first digit is a 0. So it's got to be 2.99. But now to figure out the exponent. Okay, so remember that scientific notation is about moving the decimal point. So between where it's starting here and where I want it to end, 2.99, I count 1, 2, 3, 4, 5, 6, 7. There's seven places that the decimal point has to move. So that tells me the exponent is either a 7 or a negative 7. And that's the next thing to figure out. Is it 2.99 times 10 to the positive 7th or 2.99 times 10 to the negative 7th? It's one of those. So if you go back to what we had said in the first section where we said if the exponent is negative, then you'll end up with a small number. Here we're just working the opposite way. We're saying we're starting with a small number, 0.000 whatever, 299. That's a small number. Okay, so then I'm going to have a negative exponent. So that means the negative 7, that's our exponent. So my final answer here is that this decimal, it would be in scientific notation, would be 2.99 times 10 to the negative 7th power. If I wanted to convince myself of this, I might think about the expanded form if it was a negative exponent. That could be thought of as repeated division. So divide by 10 7 times. If the ink will catch up to me here. I'm not going to write out all the tens, but this seems to work. If you know the shortcut for dividing by 10, every time you divide by 10, that decimal point moves one decimal or one place to the left. So divide by 10 once, 2.99 would become 0.299. Divide by 10 again, you get 0.0299, and etc. And it would get smaller and smaller and smaller until we would eventually get what we started with, the 0.000, all those zeros, 299. All right, going to number 13. Number 12 is another small number, so number 12 should have a negative exponent. 13 looks like a big number. We're starting with 85,200, and we're supposed to write that number in scientific notation. So again, in my opinion, the easy part is finding what's the quote-unquote single digit. Right away, we have an 8, and we want the single digit needs to be non-zero, can't be a 0. But yeah, all right, so 8's our single digit. You go, but I need the 5 and the 2. The zeros at the end, I don't need. But the 5 and the 2 I need. I go, all right, well then let's put the decimal point. So that's where the decimal point is going to end up, in between the 8 and the 5. But where does it start? Where is the decimal point at the beginning? Well, we have here a whole number. This 85,200, this is a whole number. So the decimal point really, it's not written, but it starts all the way on the right. That's where it starts. This is a comma. That's not a decimal point. That's like to separate the ones group from the thousands group. The decimal point is really starting all the way on the right. And so between where the decimal point is starting and where we want it to end in between the 8 and the 5, I count 4 digits or 4 decimal places that we would have to move that decimal point. So that tells me it's going to be 8.52. We're multiplying by a power of 10. It's either going to be positive 4 or it's going to be a negative 4. So you might think one way that, well, hey, 85,000 is a big number, so that tells me we should do a positive exponent. We should go with the 4 here. And indeed, you would be right about that. So we are going to go with the positive 4 instead of the negative 4. 8.52 times 10 to the positive 4th. So there's my answer, that 85,200, if I wanted to write it in scientific notation, would be 8.52 times 10 to the 4th. So remember, we can justify this also, or we can kind of think backwards to say if it was a positive exponent, that's repeated multiplication by 10. So if we think of it as 8.52 multiplied by 10 once, twice, 3 times, 4 times. So that ink is catching up to me here. But yeah, every time you multiply by 10, the number gets bigger, the result gets bigger. So you got 8.52 multiplied by 10 once, it become 85.2. Multiply by 10 again, it become 852. And we'd have a couple more times that we would multiply it. It would eventually end up to be what we started with, 85,200. Okay, let's do one more. Okay, so the last one we're going to look at in this video will be number 15. So 6.4, this is a regular plain number. It's called standard form, or standard notation, and we are to rewrite this in scientific notation. So we're going to start with that single digit number, and I look and I go, ooh, we already have a single digit followed by the decimal point. So I think 6.4 is our single digit number. So now I got to say, all right, so that's going to be times 10 to some power. And I got to figure that out here. Well, I'm not moving the decimal point from, not like number 13 where it was the decimal point was all the way on the right and I had to move the decimal point so it's between the 8 and the 5. Here, the decimal point is between the 6 and the 4, and that's where I want it to end. So I don't move it at all, which means 0 moves. My exponent is 0. Don't move the decimal point. 0 moves for the decimal point. The exponent 0. So that's it. 6.4 in standard form is 6.4 times 10 to the power of 0 in scientific notation. And yeah, so kind of like where we talked about writing this out in standard form, 6.4 times 10 to the 0 would just be 6.4. 10 to the 0 is 1. So this is what I just wrote down as my answer is 6.4 times 1, which is 6.4, which is what I started with. So again, this is maybe deceptively easy on this one, but the decimal point doesn't move. So, well, that's what we show with the exponent. If you don't move the decimal point, that's 0 moves, your exponent 0, and that's all we got. So I hope that video was helpful for you. We'll see you in the next one.